Hi friends, welcome back. Now we are continuing with the chapter Real Numbers. We are moving on to the topic the fundamental theorem of arithmetic. Here we are going to learn about the prime numbers, composite numbers, factors, etc. Okay. First of all, let's see what are factors. For example, we can take the number 12. Okay. 12. 12 can be divided by 2, 12 can be divided by 3, 12 can be divided by 4, 12 can be divided by 6, 12 can be divided by 1 and by the number itself 12. So all these are known as the factors of number 12. Clear? So these are factors of number 12. So what is a prime number? If any number is having only two factors, that number is called as prime number. So example 2. 2 have only two factors, that is 1 and the number itself. Any numbers having the factors as 1 and the number itself are known as prime numbers. Prime numbers. Clear? Any number having the factor as 1 and the number itself are known as prime numbers. So what are composite numbers? Just opposite to this. Any number which are not prime numbers are known as composite numbers. So for example, this 12 or example 4. Which are the factors of 4? 2, 1 and 4. So any numbers having more than two factors are known as composite numbers. Composite numbers. Okay. And now let's see what is a factor tree. See the example given here, 32760. We are factorizing the value 32760. So we are dividing the number with 2 and we are getting 16380. So we are continuing the factorization. We are dividing it with 2 again. We are getting 8190. Again with 2 we are getting 4095. And we are dividing it with 3. We are getting 1365. And then dividing with 3 we are getting 455. Dividing it 5 we are getting 91. And finally dividing it with 7 we are getting 13. And see all these numbers what we are getting 2, 3, 5, 7, 13. All these are prime numbers. So this is fundamental theorem of arithmetic that says every composite number can be expressed, means factorized, as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So what do you understand? Here example 32760 is a composite number. We are factorizing this and we are getting factors as prime numbers. So any composite number can be expressed as a product of primes. So we can get this value 32760 by multiplying this 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. And this factorization is unique apart from the order in which the prime factors occurs. Okay, so this is we can change the order. 32760 in the first step, what we can do, we can divide it with 7. In the second step we can divide it with 13, and then we can divide it 2. After that we can divide it with 3. The order can be changed, but finally the value will be same. All the prime numbers, multiplication of all these prime numbers, we will get this result as the composite number. Okay, now let's see one example here. Example 5. This is a good example. Consider the number 4 to the power n, where n is a natural number. Check whether is there any value of n for which 4n ends with the digit 0. Let's see. So 4 raised to n. n can have values of any natural number. N can be 1, 2, 3, 4, etc. N can be. So if the values of if we are checking the values of n with 1, 2, 3, 4, example 4 raised to 1 is 4, 4 raised to 2 is 16, 4 raised to 3 is 64. So the question is that any value of n, can we get a value ending with 0? Okay, for this we have to find the prime factorization. We have to do the prime factorization of 4n. Okay, prime factorization of 4 raised to n. So that is 2 raised to 2 whole raised to n. We can write as 2 raised to 2n. As 4 we can factorize like this: 2 into 2, 2 into 1. Okay, 2 raised to 2 whole raised to n. Since prime factorization of 4 raised to n does not have number 5, we know that any numbers ending with 0 will have a prime factor as 5. But here we are having 2. The prime factorization of 4n doesn't have 5. What we can say? Therefore 4 raised to n cannot end with 0 for any natural number n. Okay, we move on to example 6. Find the LCM and HCF of 6 and 20 by prime factorization method. So we can write 6 as 2 into 3. 2 and 3 are the prime factors of 6. And 20 as 2 into 2 into 5. Okay, so that means 2 square into 5. So what is the HCF of 6 and 20? That is the highest common factor in both of these, both of the prime factors. That is the number 2. So HCF of 6 and 20 is 2. What is the LCM of 6 and 20? That is 2 into 2 into 3 into 5 is the LCM of 6 and 20. Okay. Now it says HCF of 6 and 20 is a product of the smallest power of each common prime factors in the numbers. And LCM of 6 and 20 is the product of the greatest power of each prime factor involved in the numbers. We know this, we have learned in the previous classes. Okay, but a new thing we are going to see here is that, see, from these examples we can find HCF of two numbers multiplied by LCM of two numbers gives the product of the two numbers. So with this we can find the LCM of two positive integers if we know the HCF of these numbers. Okay, so we will see another example. Find the HCF of 96 and 104 by prime factorization method. Hence find their LCM. See, prime factorization of 96 and 404. So let's see this. Okay, let's see. Which are the numbers? 96 and 404. So we can do the factorization first. 2. 2 again. 2, 4. 2 again. 12. 2 again. 6. 2 again. 3. Okay, so what are the factors of 96? 2 into 2 into 2 into 2 into 2 into 3. That is the factors of 96. Same here, 404. We can start with 2. 202. 2. 10. So we can write 96 as 2 into 2 into 2 into 2 into 2 into 3, and 101 as 2 into 2 into 101. This is 1, 2, 3, 4, 5. 2 to the power 5 into 3. This is 2 to the power 2 into 101. So what is the HCF of these two integers? The highest common factor in both these. HCF of 96 and 404 is equal to, which is the common here? 4. 2 raised to 2 is here, 2 raised to 2 is here, is 4. Now we have to find the LCM. LCM of 96 and 404. As we said, now we can find the LCM by dividing the product of the numbers with the HCF of these numbers. Okay,